Hello, so this is going to be the second half of section 7.1. So we're still in section 7.1, and I'm going to be covering the reciprocal identities and the cofunction identities. Okay, so we define secant theta to be 1 over cosine theta, cosecant theta to be 1 over sine theta. And then you can say that cotangent theta is 1 over tangent theta. Okay, and we're going to use this property in algebra, which states that if you have a fraction, a over b is equal to c over d, then eventually you can do some steps in between and show that b over a is the same thing as d over c. And what is that step? Well, the first step would be to cross multiply. So a times d, b times a. This is really equivalent to multiplying both sides by BD. So if I multiply the left side by BD, I multiply the right side by BD. So what's going to happen to the left side? B will cancel, D will cancel, and so A times D is equal to B times C. And then now, what you do on both sides would be just to divide both sides by AC. So if I divide the left side by AC, I'll divide the right side by AC, and then the A will cancel, the C would cancel, and the final step will be just to flip the left side with the right side. So here I prove that D over C is now going to be equal to B over A, and here I'm just gonna make the right to be the left and the left to be the right, and I have B over A is the same thing as D over C. So if you have two fractions that are equal, you can flip the left side, and that's the same thing as flipping the right side. And that's what we're going to do with this, each of these equations. Secant is not a function, not a fraction, but I can make it into a fraction. Secant is the same thing as secant theta over 1. So once you rewrite it as a fraction, we'll flip both sides, and we'll get, so let me move it down here. We'll make that into 1 over secant is equal to cosine theta over 1. So really, cosine theta is the same thing as 1 over secant theta, okay? Or really, cosine theta is 1 over secant theta if I move cosine to the left side. So that's going to be another reciprocal identity on top of these three. So once I establish an identity, I'll circle that in. Okay? You do the same thing for the other two identity. So if I were to take this one, that is cosecant theta over 1. That's going to be equal to 1 over sine theta. Okay? Flip the left, flip the right, you get 1 over cosecant theta is equal to just sine theta over 1, but I'll just write it as sine theta. And so that's going to give us sine theta is equal to 1 over cosecant theta. And you'll see that a lot of these identities, you start with something you know already and you play around with it and you get something new out of it. Okay, one last one. So cotangent theta is equal to 1 over tangent theta. That means that first you rewrite it as a fraction. You flip the left side, and then you'll get to flip the right side. And I'm gonna do 2 steps here. Really, you flip it, and then I'm going to just remove that 1 because dividing by 1 is just itself. So tangent theta over 1 is just tangent theta. And then finally, I'll write that tangent theta on the left side. Okay. All right, there is one more, and that's coming from this third identity. Instead of flipping the left and the right, I can rewrite this tangent as sine over theta. Okay, so there's one more. So cotangent theta is going to be 1 divided by tangent theta, but tangent theta is really sine theta over cosine theta. And if you divide by a fraction, that is equivalent to multiplying by the reciprocal. So this is 1 divided by this fraction. So that's equivalent to 1 multiplied by the reciprocal of this fraction. So that's going to be cosine theta divided by sine theta. And so finally, cotangent theta is equal to cosine theta divided by sine theta. Okay, so these are all the reciprocal identities. Okay. All right. The last set from section 7.1 would be the cofunction identities. So for this one, you can easily prove it from using SOHCAHTOA. So if I just observe a right triangle and I'll call this guy theta, then the remaining angle must be really the leftover of the 90 degree. So we know the sum of all 3 angles are 180. Here we already have 90. That means the sum of these 2 must be 90. So if this is theta, wherever this is must be the leftover of the 90. So that's equivalent to saying 90 minus theta. All right, so for example, if theta was 20 degree, this angle would be 70 degree, and that's coming from 90 minus 20, which is 70. Okay, so these are called complementary angles. So I'm gonna call this side A. I'm gonna call this side B. I'm gonna call this side C. I am not going to call this adjacent or opposite because really it's all relative to which angle you're referring to. So A would actually be adjacent if you're referring to theta, but A would be opposite if you're referring to this angle 90 minus theta. So I'm just gonna call it by A, B, and C. Okay. Then by SOHCAHTOA, if I want to know what cosine of theta is, this is going to be equal to adjacent, which is A, adjacent to theta, over hypotenuse, and that's C. So cosine theta is going to be A over C. Okay. How about sine of 90 minus theta? Sine of 90 minus theta, well, sine, according to SOHCAHTOA, would be opposite over hypotenuse, and that's relative to 90 minus theta. So opposite of 90 minus theta would be A, and hypotenuse would still be C. So sine of 90 minus theta would be also A over C. Okay. Well, so if cosine of theta is A over C and sine of 90 minus theta is A over C, that means that cosine of theta must be equal to sine of 90 minus theta. And that's going to give us a new identity. So they're equivalent. So that's why this guy is called a cosine, and this is the sine. Cosine is the cofunction of sine. And you can do this for tangent as well as secant, cosine, cotangent, cosecant. Let me do one more example with you guys. So let's do another pair. So cosine, this is the cofunction of sine. What's another cofunction pair? Well, tangent and cotangent. Okay. So they should share a similar identity. So let's do a tangent of theta. So what's tangent of theta? Well, tangent is going to be opposite, which is B, over adjacent, which is A. And I'm going to take cotangent of the complementary angle, not theta, but 90 minus theta. Okay, so what is cotangent? Cotangent is not opposite over adjacent. Cotangent is actually going to be adjacent over opposite. And I'm taking cotangent of 90 minus theta. So in reference to the angle 90 minus theta, I'm going to look at adjacent, which is B, and opposite, which is A. So cotangent of 90 minus theta will be adjacent over opposite. So that's going to be B over A. And look at that, that's the same thing as tangent. So again, we'll write tangent of theta is the same thing as cotangent of 90 minus theta. Okay. All right. And you can do this for any other pair. So let's do secant and cosecant, right? So cosecant and secant, they're a cofunction of each other. So if I do secant of theta, what should I get? Well, recall that secant is the reciprocal of cosine. And so here's theta. Cosine is adjacent over hypotenuse. So secant is going to be hypotenuse over adjacent. So this is going to be C over A. And I'm going to take the cosecant of the complementary angle, and that's going to be 90 minus theta. And so in reference to this angle, I'm going to look at, what is cosecant? Well, cosecant is 1 over sine. So cosecant is the reciprocal of sine. And sine is opposite over hypotenuse. Therefore, cosecant is going to be hypotenuse over opposite. So that's going to be C over A. And look at that. That's the same thing as secant of theta. So here, secant of theta is going to be the same as cosecant of 90 minus theta. Okay, so the relationship between the cofunctions would be either the same if you take the evaluation of theta and the evaluation of its complementary angle. So secant of theta is the same thing as cosecant of 90 minus theta. Tangent of theta is the same thing as cotangent of 90 minus theta. Cosine of theta is the same thing as sine of 90 minus theta. And you can actually switch them around. So maybe you should try to prove the last three here. If I were to do sine of theta, this is the same thing as cosine of 90 minus theta. Okay. And here, if I do cotangent of theta, this is the same as tangent of 90 minus theta. And cosecant of theta is the same thing as secant of 90 minus theta. That's it. Now I'm assuming the unit of the unit of the angle is in degree. I can rewrite these 6 identities again in radiant mode. So, for example, if theta were in radiant, then this identity would be equivalent to cosine of theta is equal to sine. And what's 90 degree in terms of radiant? It is pi half minus theta. For this guy, tangent of theta is equal to cotangent pi half minus theta. And then this third guy would be secant theta is equal to cosecant of pi half minus theta. Okay? They're really the same thing, except one guy is in degree, the other guy is in radian. And that's it. All right? Okay, so that's it for all the identities. In this section, we're going to learn how to prove identities. And so you start with an equation, and you have to show that it's true. So I'll give you guys one example. So for example, we want to prove that sine of theta multiplied with cotangent of theta is equal to cosine of theta. Okay, so in order to prove this, you can't assume that the equation is true, and so you can't just start off by writing the equation. You have to start on one side and work your way to the other side. You can select the left side to begin with or the right side. A wise choice would be to pick the side that is the most not simplified, the one that has a lot to work with. So in this case, I would pick the left side because here it seems like I can do something with this cotangent, simplify it with the sine, and get this cosine. Okay? So I'm going to start with the left-hand side. So we call that LHS. And so my left-hand side would be sine of theta multiply with cotangent of theta. And I'm going to do something with this to eventually get this to become just cosine of theta. And I'm going to justify each step. So for my first step, I am going to rewrite cotangent, still keeping the sign, and I'll rewrite this cotangent as in terms of sine and cosine. So cotangent will be cosine of theta over sine of theta. So here I applied an identity, and the identity would be the reciprocal identity. And it's the identity where cotangent of theta is equal to cosine of theta over sine of theta. Okay. All right, so that's my first step. My next step would be just to cancel out the sign. So if I cancel out the sign, that would be an algebraic step. So I'll just say algebra. And you can just simply cancel out the sign, because sign here is in the numerator, this sign is in the denominator, and so you're left with just cosine of theta. And that's it, because here, that's exactly the left side, the right side. So this is the right-hand side, and once you're able to get to the other side, you're done. So this proves it. It is just 1 and 2 step. Okay, so that's the first example. Here's the next example. So I'm going to prove that sine of theta is equal to 1 minus cosine square of theta divided by theta. All right, so this is the left-hand side, this is the right-hand side. I'm going to have to begin on one side and get to the other side. If I begin on the left side, you'll see that somehow from this one single sign, I have to build this up to get 1 minus cosine square theta over sine theta. That's not an easy task. It's a lot easier to start with something that is a mess and clean it up and get something that looks a little bit more simplified. So here I'm going to start on the right-hand side, which is 1 minus cosine square theta divided by sine theta, and apply some identity, maybe a few identities, and eventually get this to become just sine theta. Okay, and so the first identity I'm going to apply would be the Pythagorean identity. It's not really a direct application of the Pythagorean identity, because the identity is sine square theta plus cosine square theta is equal to 1. So we have to really modify this identity a little bit. So if I move this cosine square over to the right side, we get a different version of this identity. Sine square theta would be equal to 1 minus cosine square theta. Okay, so I get to replace this 1 minus cosine square theta with just sine square. And we're keeping the sign underneath. We're not doing anything with that. Okay, so here this step is justified by this Pythagorean identity. And then one more step, we get to cancel one of these signs. I have sine square on top, I have sine on the bottom, so we're left with just sine theta. Well, that's exactly the left-hand side. And once we get to the left-hand side, we're done. Okay. All right. And that's it for the notes. I'm going to make one more video on the homework from section 7.1, and then I'll move on to section 7.2 notes.